Hello, everyone. Welcome to the last few lessons for the end of the school year. This is what I'm going to be calling Algebra 1 Essentials. And we're going to be starting off with rate of change. In these lessons, we're going to be going over the main topics that I believe you need to know in order to be successful in any other math course moving forward. And rate of change is definitely one of the most important things. Here are the IXL codes that you will be completing at the end of this lesson. I will be entering one grade into PowerSchool. So in order to do that, I'm going to be taking your SMART scores, whatever you get for both of these assignments, and I'm going to be taking the average of those grades. That's how I'm going to determine what grade I'm going to enter into the gradebook. And it's all going to be based off of this table down here. If you need a reminder, the average can be calculated by adding two numbers, or in this case, both of these scores, and we're going to divide them by 2. We're dividing by 2 because that's the amount of numbers that we're adding up together. So for example, let's say that you earned a score of 50 in one and then 80 on the second assignment. When you add both of those up and divide it by 2, you'll get a 68.
Pause. All right, so I messed up. What I meant to say was that 56 plus 80 is equal to 136, and then that divided by 2 is equal to 68. I messed up. This would have given you 135 divided by 2, which would have given you 67.5, but I didn't want a decimal. I just forgot to change that 55 into a 56. My bad. Hopefully that's not too confusing. Everything that I say moving forward is still accurate. All right, let's get back to it.
So I will be answering, according to this table, a 68 would be, it's between 10 and 69. It's just shy of passing. Make sure that you are calculating your own average ahead of time just to make sure that it's something that you are happy with. You choose what you want to get. If you want to prove to me that this really makes sense to you, you should be aiming for that 90 or 100. In this lesson, we will be reviewing rate of change, and we're going to be talking about rate of change in two main situations, when we're talking about tables and when we're talking about graphs. For this assignment, you will need some sort of paper or writing utensil just to take down some notes and to work out some numbers when I ask you to do so. You can use a calculator if you'd like. I would prefer if you try to do most of the work by hand, but you can use a calculator if that is easier for you. Here is the first example that we're going to be doing. The examples that we're going to be working with are going to be pulled straight from IXL just to make sure that you have an idea of what these examples are going to look like, and that way you don't have any questions when you go ahead and start working on them on your own. Let's just start by reading the problem together. A vendor who sold bread at farmers markets counted the number of leftover loaves at the end of each day. Here we see a table. It's titled Loaves of Leftover Bread. On the left side we see days and then leftover loaves. The question asks, according to the table, what was the rate of change between Tuesday and Thursday? Every time you read one of these problems, the beginning section is just going to provide you some context. So all that means is that it's just telling you what this problem is talking about. Here we're talking about days, we're talking about leftover bread. It's kind of like the story, the background. We're going to be using the table, but we first need to know what we're looking for. Looking at the question again, the most important part that stands out to me is the word rate of change, which makes sense because that's the title of this whole assignment. And more specifically, they tell us that we're looking for the rate of change between Tuesday and Thursday. So the next thing we need to ask ourselves is, what does rate of change mean? There are a bunch of different ways that you could think about rate of change, but the most general way, the way that I need you to remember, is that rate of change is simply the change of y over the change of x. So because of this definition, because rate of change just means change of y over change of x, we need to know the y and x that we're talking about in this problem. Take a look at the table and try to think about which section should represent the x and which section should represent the y. If you said that x was days and y was leftover loaves, then you are correct. Again, X just means independent variable, Y means dependent variable. So let's go ahead and find the rate of change then, if we know that days is X and leftover loaves is Y. Let's go back to these days that we were given back here. We're being asked to find the rate of change between those days, Tuesday and Thursday. Looking back at the table, on Tuesday we know that there were 14 leftover loaves, and on Thursday we know that there were 24 leftover loaves, and that's important for us to know. I'm going to start off with finding the change of X. In this case, it's just a change of the days. So if I'm asking myself what is the change from Tuesday to Thursday, all I'm asking is how many days passed. From Tuesday to Thursday, that's just 2 days. So my change of X is 2. For the leftover loaves, on Tuesday we had 14, and then on Thursday we had 24. So the change from 14 to 24 in this case is 10. So my change of Y, my change of leftover loaves is 10. This fraction, 10 over 2, is technically correct. That is the rate of change. However, we can simplify this. This just says 10 divided by 2. 10 divided by 2 is just 5. So the rate of change in its simplest form is 5. Here's a problem for you to try on your own. As a reminder, we're being asked to find the rate of change, and like we said before, the rate of change is simply the change of Y over the change of X. Go ahead, take 30 seconds, see how far you can go. If you need more time, pause the video and press play when you're ready to go. Your time starts now. Your time is up. Let's talk about this problem together. For this problem, we're being asked to find the rate of change between 2010 and 2011. In 2010, the record time was 24 minutes. In 2011, the record time was 22 minutes. This one's a little straightforward, but there's a little detail that I want to make sure that you pick up. Here we have years as our X, our record time as Y. The column on the left will always be your X, the column on the right will always be your Y. That's just how we organize our work. The change in X from 2010 to 2011 is just 1 year. So here in my fraction, change of X is going to be 1. For change of Y, the change is 2 because it goes from 24 to 22. However, what I just wrote down is not correct. There's a small little detail we need to make sure that we notice. If we look at 24 and then at 22, we could see that it goes down 2 minutes. So that should be a -2. So in our answer, this should be a -2 over 1, which when we simplify, -2 divided by 1 is just -2. So here our rate of change is -2 minutes per year. This last example for tables is going to ask us to do an extra step. If you notice near the end of our answer, it's going to ask us to round our answer to the nearest tenth. So apart from the rounding, everything else is still the same. It's still the same thinking process. Here we're being asked to find the rate of change between 2010 and 2013. In 2010, we had 543 employees. In 2013, we had 550 employees. Because we know we're looking for the rate of change, we know that we should be looking for the change of Y over the change of X. Remember that years is X, employees is Y for this problem. The change in years from 2010 to 2013 Well, that's 3 years. Because the number goes up from 2010 to 2013, my change of x is going to be a positive 3. For my change of y, the number goes from 543 to 550. Because that number goes up, it's going to be a positive number, and the change here is 7. So here my change of y is 7, my change of x is 3, so my rate of change is 7 over 3. If you're wondering how I got that 7, let's just remember what the word change means again. Remember that change of y, that word change just means subtract. This would have been the same thing as saying 550 minus 543. That is a change of y. I am subtracting the y values for this problem. We could have done the same thing for change of x. We have the change of 2013 minus 2010. So we're just subtracting those years. 2013 minus 2010, that's how we get that 3 down here in our denominator. 550 minus 543, that's how we got the 7. But again, we're not done because our answer is actually supposed to be a decimal. If we type this into our calculator, 7 divided by 3, we're going to get an answer of 2.33333, and it's going to go on forever. So that's why we put the little line on top to represent that it continues, it repeats. We're being asked to round to the nearest tenth. As a reminder, the nearest tenth is this number right here, the first place value after the decimal. The next question that we're asking ourselves is, does that 3 go up or does it stay the same? If you remember from middle school or from class when we reviewed this together, we need to look at the number next to the one that we just underlined. So we're going to look at the next 3. And if you remember, the little rhyme that we use goes like this. It's 5 or more, raise the score, 4 or less, let it rest. Because this number is a 4 or less, it's a 3, we're going to let our number, the 3, this one right here, we're going to let it rest. Meaning that our final answer is going to be 2.3. And that's it. That's what you will enter as your final answer in IXL. We are going to be doing something very similar, but this time we're going to do it with graphs. This problem says, Ms. Becker told students how many rounds to expect in the spelling bee based on previous years. Then we have a graph, and then the question says, according to the graph, what was the rate of change between 2008 and 2011? So again, we are looking for the rate of change, and then they give us the 2 years that we're looking for, 2008 and 2011. Because we're looking for rate of change, we know that we're going to be using change of y over change of x. The next question is, which one's y and which one's x? Well, for this one, the x-axis is the horizontal one, the one that goes side to side. So x has to be years, and that means that y has to be rounds. So for this problem, in 2008, we had 15 rounds of spelling bee. In 2011, we had 6 rounds of spelling bee. Let's find the change for years first. From 2008 to 2011, the change was 3 years. And you can see this pretty clearly here. 1, 2, 3. 3 years. So in my fraction for my change of x, I'm going to put a 3 in the denominator. For change of y, we're going from 15 rounds to 6 rounds. So clearly we're going down. We go from 15 to 6. So the change from 15 to 6, that is a change of 9. And because we went down 9 units, this should be a negative 9. So negative 9 is our change of y. And that means that negative 9 over 3 is our rate of change. But again, we can simplify this. Negative 9 divided by 3 is the same thing as saying negative 3. So the answer for this problem is going to be negative 3 rounds per year. That is our rate of change. Here's one for you to try. You have 30 seconds, see how far you can get. If you need more time, pause the video and press play when you're ready to go. 30 seconds starts now. Let's see how you did. The question says, in trying to calculate how much money could be saved by packing lunch, Maria recorded the amount she spent on lunch each day. Here we have our graph. Let's go ahead and look at it a little more closely. We have the amount spent here and then the number of days on the other side. We know that amount spent because it's the y-axis, it's going to be our y value, and then days is going to be x. The question asks, according to the graph, what was the rate of change between Sunday and Thursday? Looking back at the graph, on Sunday, Maria spent $8, while on Thursday, she spent $10. We know that because we're looking for rate of change, we are looking for the change of y over the change of x. The change of x is going to be the change of days. So starting on Sunday, the change was 1, 2, 3, 4. The change of x is 4 days. The change of y, the change in amount of money spent, went from $8 on Sunday to $10 on Thursday. So the change was $2. Because the price went up from $8 to $10, it's going to be a positive 2. 2 divided by 4 can be our final answer, but we first have to ask ourselves, can we simplify it? In this case, we want to know, is there anything that we could divide the top and bottom by? And in this case, yes, we can. We could divide top and bottom by 2. So let's go ahead and divide top and bottom by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So your answer here is also 1 divided by 2. And if you enter that as a decimal, 1 divided by 2 is just 0.5. Any of these answers would be correct for this problem. For this last example, the situation is a little different. Instead of entering a final rate of change or a final answer, this time we're going to be asked to compare two different rate of changes. The problem says, Annette entered the amount she charged on her credit card each month into a spreadsheet. She's very responsible. I should do that too. On the y-axis, we have the amount of money that she charges onto her credit card. And on our x-axis, we have the amount of months, or the months that she tracks this for. The question asks, according to the graph, when was the rate of decrease greater? We haven't seen that yet, rate of decrease, but it's actually a little simpler than you think. When we're talking about rate of change, we could either have positive rate of change or negative rate of change. So a positive rate of change looks something like this. It's when the line or the graph is going from left to right in the positive direction. On the other hand, you might have something like this, where it looks like the line is going down from left to right. And when you have that, we consider that to be a negative rate of change, or in this case, a decrease. For this problem, we're finding when was the rate of decrease bigger? So which one was going down more? Let's erase this one real quick. Let's start with June and September. In June, the amount of money that she charged onto her card was $100. And in September, the amount of money she charged was $55. I'm going to label this option option A. So for option A, our change of y over change of x is equal to, from June to September, that was 1, 2, 3. That was a change of 3 months. So I'll put a 3 in the denominator. And for my change of y, it went from 100 to 55. That is going down. It's going from a bigger number, 100, to 55, and that is going to be 45. And again, because it's going down, this should be a negative 45. It decreased from 100 to 55. It went down. Let's erase this as well now. Let's try option B. For option B, we're looking for the rate of change between July and August. So July and August are right here next to each other. In July, she had a charge of $80. In August, she had a charge of 75. Now let's find the change of y over the change of x. Let's find the rate of change. The rate of change is pretty simple. We're just going from July to August, so that is a change of 1 month. So that's pretty straightforward. So 1. For change of y, we start with $80 and then we go down to $75. So that drops by $5. So which one's correct? Which one is more negative? Which one has a bigger decrease? If you were to simplify these, you would get a negative 15 here and you would get a negative 5 right here. So which one's more negative? The one that's more negative is negative 15, option A. And that's it. Those were just some examples of the type of problems that you will be seeing on your assignments. Again, if you have any questions, please let me know. I know that the rounding might be a little confusing for some of us. Let me know if you have any questions so I can help you out. Remember that I'll be taking both of your scores for both of these assignments and I'll be finding the average. And depending on your average, I'll be giving you a score based on the table right here. Please be productive, get working. I'll see you all later. Take care, everyone.